So just like with index laws, logarithms also have laws, and there's a few of them. So we're just going to go through each of them, the first two individually, and then we'll just sort of run over the next ones and go through how to use the rule. So the first thing that you need to know is, suppose that log A of B is equal to X and log base A of C is equal to Y. Then if we were to rearrange that into the exponential form, we would have B is equal to A to the power of X and C is equal to A to the power of Y. So we also know that if we were to do A to the power of X times A to the power of Y, we would get A to the power of X plus Y. That's using our normal index laws. And the same thing as if we did A to the power of X divided by A to the power of Y. Using our index laws, we would do A to the power of X take Y. So what I've done there in terms of B and C, we're saying if we multiply B times C, then we get A to the power of X plus Y. And if we do B divided by C, we get A to the power of X take Y. So if we write these as logarithms, it means that we're doing log base A of B times C is equal to X plus Y, and log base A of B divided by C is equal to X take Y. So in terms of the actual laws, our first two log laws are a bit similar to the first two index laws. So we've got, if we have log of base A of B times C, that then simplifies to log base A of B plus log base A of C. And same with the last one on the page there, we've got log base A of B divided by C. We would do log base A of B, take away log base A of C. And that just goes back to that very first statement on the first page, was where we defined X and Y. And I just went through and showed you how we got the X and the Y, and then how we put it back into those log laws. Now they are going to make a lot more sense a little bit further into the video when we do some examples to do with all of the log laws. So that's law 1 and 2. The next one is, if we again allow log base A of B to equal X, then we know that B is equal to equal to A to the power of X. And we know from our index laws that if we do A to the power of X all to the power of N, we end up with A to the power of X times N. So that's the same as saying B to the power of N is equal to A to the power of X times N. So now if we write it as a logarithm, we end up with, if we rearrange that into log form, we get log base A of B to the power of N is equal to N times X. And just above here in that first part, we defined X as log base A of B. So in the red box here, I have the third log law, which is log base A of B to the power of N is equal to N times log base A of B. The other ones that you do need to know is, and these ones are quite handy because they come up quite a lot in non-calculator sections of exams and tests. And it's A to the power of 1 is A. We all know that. If we do 3 to the power of 1, we get 3. If we do 5 to the power of 1, we get 5. So in terms of logarithms, if we reverse that exponential into log form, if we've got log base A of A, it means it's 1. And the same with the anything to the power of 0 is equal to 1. So if you've got log base A of 1, that's going to equal 0, because that would normally be A to the power of 0 and equals 1. We've just reversed it into log form. And the last one is just a bit of a similar one to the third law, where if we've got log base A of 1 divided by b, then it's just the negative version of log base a to of b. So example 1, express as a single logarithm. So what we're looking for here is we're trying to use our log laws to get it into one logarithm. So at the moment, we've got 3 different logarithms. So you can see they're all in the same base. They're all base 10 because there's no base listed. So we've got log x plus log y, take away 3 log z. So log x plus log y. If we just have a look at that section, I'm just going to underline that. If we just have a look at that section there, we're going to have log x plus log y. Now, because it's an addition, that means we actually did a multiplication for the logarithm. So it would be logarithm of x times y. Then, if we have a look at the 3 log z, okay, if we go back to our log laws, it's this one here where we have n log base a to the power of b, sorry. So we would end up with log of z cubed. Now, we also need to, I'm just going to underline that in red, and then we also need to look at this take sign in the question as well, and that take sign means that we're now dividing xy by z cubed, because the log laws state that if there is a takeaway, it means that the single logarithm was a division of the 2. So we end up with log of xy over z cubed as our final singular logarithm. The next one, again base 10, log x plus 1, take log y. So log x plus 1. Now this 1, we need to work out what that means. And if we go back to our log laws, if we had an answer of 1, it means that the base is the same as what we're finding the log of. So in this case, they're all in base 10. So we're going to have log x plus log, I'm going to write the bases in, so 10 and then 10 plus log, take away log y. So now, if we have that, we've got an add sign, which means this first part is a multiplication. So we've got log of 10x, take log of y. So now that we've got that subtraction sign, we end up with log of 10x over y as our final answer. Example 2, we need to simplify this expression here, which is they're all in base 2. So we've got log base 2 of 12 plus log base 2 of 36, take 3 log base 2 of 3. So I'm just going to note there that it's the same base, because that's really important, because the fact that they're the same base means that we can apply the log laws. So what we can say is that we actually have here log base 2 of 12 times 36, and the reason it's 12 times 36 is because there's that plus sign. And then we've also got a subtraction sign, so it's going to be divided by, and now we just need to simplify this 3 log base 2, 3. So in using the log law that's n log a b, we're going to end up with 3 cubed here, because this this first number n goes as the power of that last number there. So now if we actually work this out, we've got log base 2 and we've got 12 times 36 over 27. Now we want to do this without a calculator, because that, usually they are without a calculator. So if I cross the 3 cubed out and make it 27, I can then simplify the 36 and the 27 because 9 goes into those 4 times. It goes into 36 4 times and into 27 3 times. And then I can also cancel that 3 out with the 12 and make it a 4 and a 1. So now I've got 4 times 4 divided by 1, which just gives us 16. So now we actually need to solve this. So what we're saying here is we've got log base 2 of 2 to the power of 4. Now, if we've got 2 to the power of 4, we can bring the 4 down the front because that's what we do with our log law back here. We bring the n to the front, and we would end up with log base 2 of 2. Now, if we use our minds and cast them back to what happens when we've got logarithm base 2 of 2, so the same a and b there, it means that it's 1. So that's just going to be 4 times 1, which we know is 4. And that's our answer to that one there. So again, all we did was we have a look at what operations are in here. So we have a look that there's a plus sign and that there's a take. And then we also look for the fact that there's a coefficient in front of one of them. So we need to know, what do we do with that coefficient? Well, we bring it as the power of the b there. Next example, if log base a of 4 equals p and log base a of 5 equals q, express each of the following in terms of p and q. So log base a of 20. What we're looking for is, how do we get 20 from the numbers 4 and 5? So the only way we can do that is by multiplying them. So what this actually equals is, this is log a of 4 times 5, which means it's log base a of 4 plus log base a of 5. And then if we have a look at what they were defined as, that is p plus q. And we would leave it like that because we're asked to express them in terms of p and q. So again, for the second example where we've got log base a of 0.8, we're looking for, how can we make 0.8 from the numbers 4 and 5? So to do that, we would have to do 4 divided by 5. So we would end up with log base a of 4 over 5. And if we have a division, it means we're doing log base a of 4, take away log base a of 5, and then that would be, again, we look at what they're defined as. That first one is p, and the second one is q. So we would end up with p take away q. So the next one is a little bit more complicated, and what we're going to do first is we are actually going to split this 100a squared up. So we're going to have log a of 100 and add log a of a squared. And that's because we've got 100 times a squared, so we can split that up into an addition using our first log law. Then we need to work out, how can we make 100 from the numbers 4 and 5? Well, to do that, we could do 4 times 25, which is the same as 4 times 5 squared. So we'll have log base a of 4 times 5 squared. And then we're going to also, in the same step, bring that power of 2 down the front, and we're going to have 2 log a of a. And you should be seeing and thinking now, this log base a of a is going to be 1. So we're just going to end up with a number here. So then we have log a of 4 plus log a of 5 squared plus 2 times 1. So we need to then have a look at what we can do about the log a5 squared, and we also need to simplify that 2 times 1. So at the moment, so far, we've got p plus, we're going to do 2 log a to the power of 5 because all I've done there is bring that power down to the front using our log law. And I'm just going to put plus 2 on the end. So now log a 5 is the same as q. So we're going to have p plus 2q plus 2 as our simplified answer there. So that is a bit of a crash course in log laws. These laws take a lot of practice. So the only way to really understand these is to get started on some questions and keep referring back to this if you need to.